Merge sort is a divide and conquer algorithm. So we're going to start off with a really, really big problem. So we have a really, really big array that we want to sort. What we're going to do is instead of one algorithm or one strand of the algorithm solving the entire big problem, we're going to break it in half and let other strands solve those smaller problems. Okay? So what we're going to do is break this in half. Break this in half, and now instead of one strand solving the whole big problem, now we have two strands solving smaller ones. However, this is still, you consider this can be another big problem. So what we're going to do is so we're going to have, now instead of this one strand solving this big problem, now it'll have two more strands. So you can see that it's going to exponentially increase the number of instances that are running on the array, but it actually will decrease the amount of time we have to do it because we're solving smaller and smaller problems each time in parallel. So what we do is eventually keep splitting and splitting and splitting until we get down to the base case of single elements. In practice, in real life, you wouldn't actually code it down to single elements. It'd be a lot faster to have it, say, size 500 or 1,000 or maybe 5,000 into an n-squared algorithm on it. But if you're sorting hundreds of thousands of elements or millions of elements, you're going to want to split it into smaller problems and have n-squared algorithms run on it in parallel. But theoretically, you're going to continue the split until you get down to single elements. Once you get down to single elements, now what you want to do is start merging them back together. So now, this strand up here, when we split, sorry, not this specific one, but the strand that split these two apart is now going to merge back together. So it's going to look at both of these, say whichever one is smaller, put to the left, whichever one's bigger, put to the right. Okay? So each of these is going to get combined back into two arrays, okay? And then each of these is going to get combined back into an array. So A, B, maybe whatever elements are in there. Okay? And then maybe the split. So here, now we end up with 6 more elements. And eventually what we're going to do is build back up to this large array. Okay? So this is theoretically how it works. Really fast example. 8, 2, 4, 6, 3, 1, 5. Okay, so what we do is there's 3 elements and 4 elements, so it's, or let's say 4 and 3. So we're going to have 8, 2, 4, 6, 3, 1, 5. Okay? Now, we can split this in half. So we have 8 and 2, 4 and 6. We'll split this, sort it in half. 3, 1, 5. Okay, so keep splitting. So we have 8, 2, 4, 6, 3. I'm sorry, 3, 1. So each of these is now a single element. I should have drawn the boxes as well. So it should be more clear now what happened. Okay. So now what we can do is start merging these back together. So 8 and 2. Now we want to put 2 is less than 8. 4 is less than 6. Now here, since these split apart, 3 is still by itself. 1 is less than 5. Then now we're merging these together. So 2 is less than 4. 4 is less than 8. 6 is less than 8. 1 is less than 3. 3 is less than 5. 5 and then lastly, 1 is less than 2. 2 is less than 3. 3 is less than 4. 3 is less than 6. 5 is less than, sorry, no, that's 4. 4 is less than 5. 5 is less than 6. And then 6 and 8 are remaining. So in the end, we end up with our sorted array from where we started from. So make sure, remember to split in half until you get to single elements, then you can start merging them back together.